In this video, we're going to look at how you can cleverly draw yourself a right-angled triangle when you haven't been given one to solve certain types of questions. So, for example, we've got here, we're told that cos of x is 4/5, and we're told that x is between 0 and 90 degrees. So when I'm told something like this, I realize, oh, that is quadrant 1. For some reason, we write with Roman numerals when we're talking about quadrants. I'm not sure why, but that is the convention. Now, that is helpful because if I think about quadrant 1, I know that all of my trig ratios are positive. If you remember your mnemonic to write that it's, all students think creatively or what have you, ASTC, or just cast, we're in the quadrant where they're all positive. So the fact that cos x is 4/5, well, that makes sense. Cos of x should be positive, and then we'll know for our sine and tan we're expecting positive values. Now, in terms of what do I mean by drawing right angled triangles to make this work? Well, we're saying about the kind of in the last video about the similarity of triangles of a certain angle. So here our angle is x. So we know that all of them will be in the same ratio, right? That's the nature of these ratios. So that means I can just draw myself one of those possible triangles where you've got an angle x. So if this angle down here is x, well then I know with cos, so cos of x is car in SOHCAHTOA, so it's adjacent over hypotenuse. So I know my adjacent must be 4 and my hypotenuse must be 5. So this length must be 5 and this length must be 4. Now that is useful for working out sine because I can use Pythagoras to get the other side length. So I know that whatever this opposite is, I know, so I'm just going to call it y. I know that y squared plus 4 squared equals 5 squared. So I get what y squared plus 16 equals 25. And now if I do, so y squared is equal to 25 minus 16. That happens to be 9. How convenient. So y is either plus or minus 3. But it's a length, right? So y has to be positive. I know that y is greater than 0. So this, I can just get rid of that and just say it's 3. Now it's really easy to get, say, sine of x. Sine of x is opposite over hypotenuse, right? So it's 3 over 5 or 3/5, and it's positive because we're in the first quadrant. Likewise, tan is quite easy to get. Tan of x, well, that's opposite over adjacent, so it's 3 over 4. Again, we're expecting it to be positive because we're in the first quadrant. Fair enough. So yeah, let's have a look at another one. All right, we're trying to find sine theta and tan theta if cos theta is 2/3, and we're told we're going between pi on 2 and, so it says here pi on 2 is greater than theta is greater than 0. So that again is quadrant 1. Yeah, does that make sense? Pi on 2 is greater than theta is greater than 0. I suppose so. Typically we would more likely write it this, wouldn't we? Yes, that makes more sense to me. I'm not sure why I wrote it that way in this example, but there you have it. So we just follow the same process. So if cos theta is 2/3, did I make a mistake back here? Nope, I didn't. I've just got 2 cos examples in a row. Comes as a bit of a surprise, but that's okay. So again, we've got, so the top one, knowing our SOHCAHTOA, that one's going to be your adjacent, that one's going to be your hypotenuse. We've got 3 and we've got 2. That side is adjacent to this angle here. And the side length opposite the right angle is always going to be the hypotenuse. So now, again, we can do a bit of Pythag to get our missing side, and we can find sine and tan. So we've got what? Let's just call it y again. So y squared plus 2 squared, which is 4, is equal to 3 squared, which is 9. So y squared is what? 9 minus 4 is 5. So y is plus or minus root 5. So yeah, plus or minus root 5. but we're just going to forget about the plus minus because we know it's going to be positive. So this is the square root of 5. And so what? Sine of theta is opposite over hypotenuse. So it'd be root 5 over 3. And tan theta is opposite over adjacent. So we've got root 5 on 2. They're both going to be positive because we're in Q1, quadrant 1. Yeah, so that should be our answer. There we go. All right, we've got another one, probably a more challenging one, I suspect. So we've got tan of x is equal to -3, and we're between 270 degrees and 360 degrees. If I think about where that is down here, right? All the way around would be 360, 3/4 way around would be 270, so we're in Q4. So I know only cosine is positive, if I remember my cast rule. C-A-S-T. And this one seems a bit strange, right? You're not actually given something where it's opposite over adjacent. I know tan is opposite over adjacent, but I'm not really given anything that's so obviously that, but it is a fraction, right? -3 is -3 over 1. So I can just make myself a triangle, and even though it's negative, it's just because I'm in quadrant 4, right? You can't draw something with a negative length, so I just go, well, opposite is 3, adjacent is 1, and then that is x, and this is going to satisfy the information I'm given at the start if we're in quadrant 4. And now I can just do some more Pythag to get the hypotenuse. I've got 1 squared plus 3 squared equals, let's just call it h squared. So it's what? It's 1 plus 9, because 1 squared is 1, 3 squared is 9. So I've got h squared is 10. So h is plus or minus root of 10. Does that simplify at all? Root 10. Can't really think of any perfect squares that are factors of 10. So we'll just leave it as root 10. Now, so sine of x is going to be opposite over hypotenuse, so 3 on root 10. But we're in quadrant 4 where only cos is positive, so it's actually -3 on root 10. And I might like to write that as -3, well, I'll times it by root 10 on root 10 to rationalize the denominator. So we get -3 root 10 on 10. And then we've got cos of x is going to be what? Adjacent over hypotenuse. So it's 1 on root 10. Now we're in quadrant 4, so it is going to be positive. And if I were to rationalize that, I just get that, right? All I did was that. And yeah, so you get what? Cos of x is root 10 on 10. Okay, let's leave it there for now. Hope that was helpful.